Sigstore, software signing for everybody. Software supply chain compromises gained attention due to attacks on the chain of custody in software development. Attackers can introduce backdoors or vulnerable libraries. Software supply chain attacks affect many users and are difficult to identify. The software delivery pipeline remains a common attack vector. Software signing is a process of digitally signing software artifacts, such as files and libraries. It involves using cryptographic techniques to create a digital signature that can be verified by users or systems to prevent unauthorized parties. Most packages in popular repositories are unsigned. Sigstore is introduced as an open source service that integrates software signing into infrastructure. Sigstore uses existing identity providers to issue short-lived certificates for packet signing workflows, enabling keyless signing and automated signing. Sigstore applies building blocks from WebPKI, which stands for Public Key Infrastructure, and transparency lock systems to link software artifacts and identities, prevent malicious packaging, enable detection of unauthorized access. Sigstore is adopted by GitHub Actions, Linux distributions, and projects like Google's DistroOS. Artifact and repository signing. Artifact signing involves using a private key to sign package metadata. Repository signing extends artifact signing to include signing repository metadata to prevent tampering. Attackers can tamper with repository metadata despite packet signing, leading to vulnerabilities. Transparency logs and WebPKI. WebPKI relies on X509 certificates for trust between web servers and certificate authorities. Certificate transparency addresses the issue of multiple certificate authorities issuing certificates for the same domain. Certificate transparency maintains a public transparency log to detect certificate duplication or malicious activity. The transparency log ecosystem involves client submissions, log servers recording entries by using Merkle trees, auditors preventing forking attacks, verifiers checking the log, and an append-only, non-forkable view, like a blockchain but less expensive consensus mechanisms. Identity providers. Sigstore utilizes OpenID Connect for signer authentication. OIDC is a widely supported protocol that allows relying parties to verify the identity of end users through identity providers like Google, Facebook, GitHub, or Okta. Users can log into applications using their identity token issued by the identity provider. OIDC is based on OAuth 2.0, provides interoperability, has language support, is secure against attacks, a well-defined identity specification, and multi-factor authentication. System goals and threat model. Parties and roles. The Sigstore ecosystem consists of the following roles: signers, individuals watching for the authenticity of content; verifiers, individuals checking that content is authentic; artifact log, record of artifact metadata created by signers; identity log, record of mappings from identities to signing keys; OIDC provider, mechanism vouching that an entity controls an identity; certificate authority, entity verifying OIDC identity tokens and issues cryptographic certificates to signers; monitors, independent service ensuring neither log lies about the content held to avoid fork attacks; package repository, independent service hosting the artifact's reference in the artifact log, for example PyPy. Package repositories are not essential to Sigstore. It has three system goals. First is binding signatures over artifacts to OpenID Connect identities, ensuring a connection between the identity of signer and signed artifacts. establish a global and consistent view of the entire signing ecosystem, and providing an audit trail that allows for the detection of compromises and facilitates post-incident analysis. Attacker capabilities and motivations. Software supply chain attacks target servers and dependencies. Attackers focus on overlooked package dependencies and perform targeted attacks. Sigstore considers compromises in identity providers, man-in-the-middle attacks, and package repositories. Implementation transparency integrates with existing signature systems, which means it does not require major changes. Maintains overall security even if some steps are compromised, and Sigstore aims for minimal operational, storage, and network overhead while utilizing common cryptographic primitives. System design. Sigstore performs three major operations. OIDC issuance verifies that a client is in control of an identity. Certificate issuance associates short-lived public key certificates with identities and publishes them to an identity log. Artifact signing publishes a long-lived signature over an artifact or artifact metadata to an artifact log. Full CO performs the first and second operations. It acts as certificate authority and transparency log for OIDC identities. Recur performs the third operation. It acts as a transparency log for artifact signatures. Cosign reference Sigstore client implementation. Sigstore has three major phases. Trust setup, setting up the necessary components and establishing trust. Signing flow, the process of signing artifacts and publishing the signatures to the artifact flow log. Verification flow, verifying the validity of artifacts by checking their signatures using the artifact log. The figure shows the Sigstore key issuance flow. First, the signer goes to the OIDC provider, and once it gets a response, it goes to the identity log, which is full CO, with an issuance request, and gets a signed certificate. After that, it goes to the artifact log, record, signs and publishes the artifact, and updates the root of trust. When it's to the verifier, it fetches the artifact signature and downloads the artifact from the artifact repository. Trust setup, root of trust via the update framework. Sigstore relies on TUF, which stands for the update framework, as a secure software update framework. TUF ensures key rotation, freshness, and delegation. Threshold signatures, defends against freeze or replay attacks, handles revocations, distributes root certificates for full CO and recore. The root of trust is publicly published through live stream key ceremonies and Git repositories. Clients include TUF root metadata with root keys to verify future CA certificates. Signing flow. Sigstore relies on three online systems: OIDC provider, identity log, CA, and artifact log. Short-lived certificates, which are for 10 minutes, are used for signing in Sigstore. Sigstore leverages existing OIDC identity providers for authentication. Signing involves OIDC token retrieval, key generation, certificate signing, data signing, and signature submission to recore. Verification flow. The verifier performs a TUF key update to ensure the trusted keys are fresh. By fresh, it means the keys are up to date and not expired. The verifier checks if the claimed identity was correctly verified by the identity logged, and if the provided signature matches the content of the artifact. A final check ensures that the signature was created within the valid time window of the certificate. To verify, a user runs the command cosign verify blob and examines the output, which includes the identity of the verifier. Implementation and evaluation. For the implementation, Sigstore implemented full CO and recore for signing packages on popular repositories. The cosign tool enables container image signing and verification. Fulcio and Recore utilize the Trillium framework for transparency logs with specific functionalities for identity log and artifact log. Fulcio integrates OIDC with Google, GitHub, and Microsoft. Fulcio has approximately 5,500 lines of code, while Recore is 3 times larger. GitHub Actions integration with Cosign enables automated signing pipelines and artifact source code linkage to prevent malicious code uploads. Automated signing pipelines using GitHub Actions are highly used in Sigstore ecosystem. Here is the usage frequency and details, the daily count and moving average of new entries in the Recore log from December 1, 2021 to April 11, 2022 is shown in the graph. The data was gathered on the usage patterns of the public Recore transparency log, including the number of entries, daily usage, and entry type distribution, and there were around 2 million entries in the public Recore log. The breakdown of entry types in the public Recore log as of April 11, 2022 is shown in this table, and we can see that record count is the highest one. Different signatures formats were used for record entries, and this table shows them with percentages. The signatures formats are X509, MiniSign, PGP, and SSH, and we can see the usages for each of them. For performance, the table provides a breakdown of the time spent by Cosign on different phases of signing and verification. Measurements were taken on a developer workstation with 10 trials, and an average was calculated. Most of the time is spent on updating TOF metadata. Remote calls to Fulcio and Recore take less than a second, while local computation is negligible. OIDC sign-in time is not included in the measurements as it requires user interaction. For the lessons learned, Sigstore simplifies key management but doesn't fully address identity trust, requiring users to determine trusted identities for specific artifact signing. Human-readable identities in Sigstore can be vulnerable to typo-squatting and type confusion attacks. Integrating with systems like the update framework is recommended to manage associations between identities and artifacts, specifying authorized maintainers for packet signing. As a conclusion, Sigstore is introduced as a PKI-like system that links identity providers with short-lived cryptographic material. It enables the creation of transparency log-backed signing repositories with easy integration and reasonable security guarantees. Similar to Let's Encrypt, Let's Encrypt is an automated certificate issuance, renewal, and management processes, making it easier for website owners to enable HTTPS encryption. Sigstore aims to increase adoption of packet signing by providing centralized infrastructure with accountability through transparency. Sigstore has gained significant adoption in community repositories, and in future work it includes exploring enhancements such as integration with distributed identifiers. Thank you.